So we've learned that solving inequalities and graphing inequalities is very, very similar to solving and graphing equations. It's going to be exactly the same when we're working with word problems. It's going to feel very much like an equation. You just have that added thing of having to worry about shading and having to worry about which way you put your inequality symbol. So let's get right to it. Sammy works 2 jobs to help pay for college tuition. At Zaxby's, she earns $8 an hour. She also babysits and earns $16 an hour. She must earn at least $240 per week to make her necessary payments. Write and graph an inequality to model the situation. So first thing I'm going to do is look for my unknowns. 2 things that I know is that she earns $8 an hour at Zaxby's and 16 at babysitting, but I don't know how many hours she's going to be working at Zaxby's to help try and save up this $240 a week. And I don't know how many hours she's going to babysit. So those are going to be my unknowns. I've got X is going to be hours at Zaxby's. Y is going to be hours babysitting. Okay, notice I didn't have the conversation about which one's independent, which one's dependent, because this one, there is no clear independent variable or dependent. Zaxby's doesn't depend on babysitting. Babysitting doesn't depend on Zaxby's. It can just be random. So now let's try and write this inequality. We know that those hours at Zaxby's, however many hours she works, she's going to make $8 for every hour. So if she works 1 hour, she gets $8. 2 hours, she gets $16. So that's going to be a multiplication issue, so I'm multiplying 8 times x. Babysitting works very much the same way. I've got $16 for every hour, so that's going to be multiplication. The money she makes at Zaxby's and the money she makes at babysitting gets added together, and our goal is $240. Now, we have to think about which way we're going to write our inequality symbol. Here's how I like to think about it. This is the money that I'm earning. This is the money that is mine. This is the money that I have to spend. I would really, really like it if this amount was larger than this amount, because then I have some snack money. I can go to Krispy Kreme and get some donuts. So I want this to be larger, and that means my inequality should open towards the larger value, because it'd be okay if this goes over 240. It would also be okay, though not ideal, if it was exactly equal to, because I can still make my payment if it's exactly equal to. Now I'm ready to graph it, but the problem is we're used to seeing all of our equations that we're going to graph in that slope-intercept y equals mx plus b, or y is greater than or equal to or less than or equal to. We need to get it in this form because we need to be able to identify our y-intercept and identify our slope. This is in what's called standard form. Luckily, we've got some mad literal equation skills, and we can rearrange this so that my y is by itself. So I'm going to start by subtracting 8x from both sides. This goes to 0 because they're inverses, and then 0 plus 16y, my identity property, says that that is just 16y. Over here, those are not like terms, so I can't actually combine them. All I can do is put them next to each other. Bearing in mind that I'm trying to get slope-intercept form, I'm going to put my x term first plus my constant. Again, it doesn't really matter, but I know that I want it to look like this, so I'm going to go ahead and put it that way. All right, now I'm going to divide by that 16, again, because our goal is to isolate that y. So I'm going to divide by 16. I'm going to divide each and every term by 16. So dividing that, I get y. It's basically like I'm distributing that division of 16 throughout my entire inequality. Negative 8 divided by 16, if you were to put that in your calculator, you might get a decimal, negative 0.5 or 0 5/10. But we know that this wants to be slope. So I'm going to leave it as a fraction so that I can identify that rise and run. And then that's x. And then 240 divided by 16, if you don't know it, use your calculator. That's going to be 15. All right, so now I'm ready to graph it. As always, I've got to now have that conversation about, okay, what's my scale going to be? Because they didn't provide me a scale on this graph. So, and I don't think you guys have a graph on your paper at all, so you'll just sketch one in or use some graph paper. Whatever my y-axis is, it's got to be accommodating to this y-intercept. So I can't just count by 1 because there aren't 15 spots here. I think I'm going to count by 3 because 15 is divisible by 3, so I'll have a nice pretty spot to put that 15. 3, 6, 9, 12, 15, 18, 21, 24. That's good enough. Okay. You could probably count by 2s. You could count by 5s if you wanted to, although that'd be kind of big. There is some flexibility there. It's kind of up to you. As for my x-axis, because my slope is -1/2, that means I'm going to be going down 1 and then running 2. So we can just count by 1s there. That's fine. Okay. All right, so let's switch to a different color to do our line. I am intercepting at 15, so that means I'm going right here to my 15. And then I have a slope of -1/2, so I'm going down 1. Make sure you're not going all the way down to this 12. That would be going down 3. I'm going down just 1 and running 2. And then I go down just another 1 and run 2. Now when I go down 1 more, now I'm going to be at that intersection there. So it's a very small slope. All right, now I can do a line. That's not the tool I needed. I need a line. So I'm going to start right here. Now, this is equal to, so that means it's going to be a straight line, solid line, not dotted. That's what I meant to say. They're all straight because they're linear. So now I have to think about which way to shade so that I can identify all my possible solutions. So this line represents -1/2 x plus 15. All these values above, this is all the y that is greater than -1/2 x plus 15. And this says y is greater than or equal to -1/2 x 15. So if this is -1/2 x plus 15, then this is where y is greater than that. So my shading is going to happen above that line. And I like to use 0, 0 as a test point always. So if 0, 0 should be out of the shaded region, then it shouldn't work over here. So here's 0, 0. And if I plug that in, 0 and then -1/2 times 0 plus 15, I end up with 0 is greater than or equal to 0 plus 15, which is not true, which it shouldn't be because it's outside of the shaded region. So that means I shaded in the right direction, and these are where my solutions are. Now that last part of the question, what are 2 possible combinations? To figure that out, I just have to pull 2 ordered pairs from over here. So I could go maybe 218. Remember that X is what we used for Zaxby's, and this was babysitting. Okay, so 2 hours at Zaxby's, 18 hours babysitting would work. If I wanted more Zaxby hours, less babysitting hours, then I could come over here to 6, 7, 8, 9, and what's that, 12? So 9, 12 works, 218 works. Anything over here is going to work. And obviously the higher I get up here, the more hours and the more money. All right, good luck, guys.